Welcome everyone to this HTTPS series by Simplify Bytes. HTTPS is the most widely used protocol over internet. Now HTTPS uses both symmetric and asymmetric encryption. Let's try to understand symmetric encryption today. After a lot of thought and pondering, one day you decided to write a letter to your friend. You wrote the letter, posted it, eagerly anticipating for the response, but instead of your friend reading the letter, her father read the whole letter and now you are in trouble. No, the problem with the situation is message can be read by anyone and can be intercepted. The same problem exists across internet when we send an encrypted message. Symmetric encryption takes care of this issue. How does symmetric encryption work? We take a message which is a plain text, then we encrypt it using a key. Then you send the scrambled data or the encrypted data across the internet. And you have to use the same key to decrypt the data at the receiver end. Now there are many types of encryption algorithms that we have. Some are based on stream ciphers and some are based on block ciphers. The most popular one is AES, and we have many: Two-Fish, Camilla, Salsa, Chacha, Blowfish, Cast5, RC4, DES.
What the hell are you talking about?
Let's start encrypting a message using online AES tool and then using OpenSSL on Linux, and how the message that is transformed can't be readable. So here is an online AES encryption decryption tool which you can refer to. It's a good one. Here we need to enter text first, whatever you want to encrypt. So this is the text I entered. So there are different types of keys that you can use in AES. So there is the option of 128-bit key, 192 and 256. So we're going to use 128-bit, that is like 16 bytes. So we'll need a password which is at least 16 bytes. Let's go ahead and get a password. So if we encrypt this, this is not 16 bytes. So if you encrypt this, you get an encrypted text. So this is the text that will be sending across. So now if I use the same text and use the same secret key, so you'll be able to decrypt. This is how exactly the AES works. Now same thing can be achieved using an OpenSSL tool on Linux. We'll type our plain text message here. Hello, this is encrypted message. We'll save this file. And if we do ls, you can see the file here. Now we'll use OpenSSL tool to encrypt the message using AES 128 CBC. So we'll give the input file name with -n, the input.txt, and the output file, the encrypted.txt. Now we will give the password. That's a unique secret key. So you say password 12345. Yeah. So now if you do an ls and check, there will be encrypted.txt, but if you try to see the content of that file, it won't be readable. So it is in some salted format, you can't read it. Now we'll use the same command with an -d argument to decrypt. But here the input file will be the encrypted.txt and output file will be like decoded. We'll keep it the name as decoded.txt. Decoded.txt. Yeah, so if you do a cat and check the content of the decoded.txt, so this is the unencrypted content. Same thing you can do it using a editor. So yeah, this is how same thing can be achieved using an OpenSSL tool on Linux. So what's next in the HTTPS series? So we'll be discussing asymmetric encryption, public and the private key. Then we'll discuss the certificates and the self-signed certificates. And finally we'll be seeing the HTTPS handshake. Thanks for watching this video. Stay tuned and subscribe to this channel.